Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. So we have a medium today. So the most profitable path in a tree. So we have a tree question again. So let's see. So n nodes, 0 to n minus 1, and 0 is the root. You're given a 2D integer array, edges. Right. So it will be a list of edges that we get. So we might want to convert that later on, but let's just keep reading for now. And undirected as well. So every node I. So actually, let's see the bounds first. So we have 100,000 nodes. Yeah, and then because it is a tree, it will have n minus 1 edges. That makes sense. They are all unique, right? Yeah, so all the nodes are unique, like based on this, like the 0 to n minus 1 part. A valid tree, yeah, okay. What is BOB? So we have to find that out. Amount.length. So I'm guessing that will be associated with like the node or something maybe. Amount I is an even integer. So amount is a list of ints where the values are between negative 10,000 to 10,000. Yeah, let's find out what BOB is. So at every node I there's a gate. You're also given an array of even integers. So for some reason they're all even. So we'll have to find out why. So the price needed to open the gate at node I. Right, so if amount I is negative, you have to pay to open the gate. Otherwise, you get a reward by opening the gate. So from what I've read so far, I'm guessing like you have to find a path that maximizes the amount. But let's keep going. So right, but it is actually a game. So initially Alice is at node 0, Bob is at node Bob. So that's where Bob comes from. Every second they can move to an adjacent node. Alice moves towards some leaf node. Bob moves towards node 0. Right, so Alice is at the roots, and Bob is straightly moving towards 0. I'm guessing. We might have to look at the examples to see how this runs out. So for every node along that path, Alice and Bob, they either spend money to open the gate or accept the reward. So even though it seems like they're two different things, we are basically like just adding the value there. If Alice and Bob reach the node simultaneously, they share the price. So like they'll get half of that. And similarly, if the reward at the gate is C, right? So yeah, I'm guessing like Bob doesn't really have a choice. Like he can only move upwards. Yeah, but like if they reach the node at the same time, then they split the price or the cost. So if Alice reaches a leaf node, she has to stop moving. And because Alice is at the root of the tree, because like a tree, it doesn't have any. Wait, does it say Alice has to move down? Yeah, okay, so Alice moves towards some leaf node. So I think like one has to go down, one has to go up. And so if Bob reaches node 0, he stops moving. These events are independent of each other. Right, and if the gate is already open, you get nothing. So return the maximum net income Alice can have if she travels towards the optimal leaf node. So yeah, it does seem like she can only move down. So yeah, let's look at some examples first. So here we have like Alice at 0, Bob is at 3. So well, Bob's path is very simple, right? Because like whatever node he is in, he has to move to the root. So he actually only has one path. Yeah. And honestly, we can even like based on that to calculate, like to basically, like we can look at Bob's path first, and then from that, we can adjust the price of each of the value. Right, now I see why it is even, because sometimes like the value would be halved, so that makes sense. Let's keep going. So the above diagram represents the given tree. The game goes as follows. So Alice is initially on node 0. Yeah, okay. They both open their gates. So Alice is forced to open the first one. So like that would be -2. And because right, it's Bob. Yeah, well, Bob only has one path, so we don't have to really worry about Bob's like cost or anything like that. So yeah, so both Alice and Bob, they have to move up to node 1. Yeah, well, they only have one path, so they will share that, which is like 2, whatever unit that is. We'll just call it dollars, like $2 each, because the amount is 4 here. And so on. So now Alice can either choose like 2 or 3. And like if Alice chooses node 6, like it will be it chooses node 4 because like 4 has like 6 here and 3 is already opened, so she doesn't have to like pay to open the gate anymore. Yeah, and this case is just an empty like a smaller kind of case. So yeah, so Alice starts here. She has to pay for that, and then when she goes to node 1, it's already open. So her net income is going to be very tragic. Yeah. Okay. I can see how we can do this. So, well, the first thing you want to do is you want to sort out, like, because Bob only has one path. So let me draw that out. So, I'll write down the value instead. I think that would be a bit nicer. So we have 4 here. Then we have 2. And then what do we have? Oh, -4 and 6. So -4, 6. We know that Bob starts here. And so we have to find the depth. So we have depth here. So the root would be 0, and then like 0, 1, 2, 3. So because like one is moving up, one is moving down, we can use the depth to find out like when Alice reaches that node, whether it should be like whether like we should update the node like the value of the node to be 0, or should we update it to be half, or do we not update it at all? So yeah, so we want to find the halfway point, right? So for this case, it will be a bit nicer because well, actually it should be like pretty much the same, but like let's say Alice start at like 0, Bob starts at n. So if n is even, then like if they travel at the same path, they should meet at n minus 2, right? So like I don't know, if n is 10, like it should meet at depth 5. But if it is odd, yeah, so if it is odd, n minus 1, so there should be like n minus 1 divided by 2 plus 1, and then n minus 1 divided by 2. So so there should be a fine line. So all of these should be set as 0, and then these ones, they will be left untouched. So all of these should be set 0, this should be halved, and then this should be untouched. So we can use that technique to basically update the values, and then let's say like after we have updated the value, so there should be 0 here, and then this will update it to 2, and then everything else after that is untouched. And so Alice has to find, well, basically the optimal path, like from top to bottom. So how do we do this? Well, we can just get the maximum path. So we can do recursion for each of the path, for each of the subtree. So like if we can find the maximum path here, like we can just like add -2 with it, right? And then like we basically like keep going down. And how do we find the maximum? Well, that would be really simple, because well, let's say I have another tree here. Maybe I'll make a generic case. So let's say we have a subtree here. So we have more stuff up there. And then, well, does it say it is a binary tree or not? Well, it doesn't say it is a binary tree. So we could have like multiple paths. But if we get the maximum for each of the for each of the paths, like of its child, well, we can just get the maximum of this, and then we add the value, and that will be the maximum value of this node, right? So we can definitely just do recursion on it. Yeah. So yeah, and that will also be ON, because we are only traveling each node once. Yeah, and well, you might say like the maximum here, like we could have like a lot of nodes here, but every node will only be included in the maximum once. So like that's also still ON. Yeah, so the last thing we have to think about is how do we want to actually set the, like how do we want to turn the edges array, I guess. So maybe we definitely want to do a DFS, and I think what we want is we want parent. So we want a parent array. So empty. So empty for, I think in range. Maybe we want to set number of nodes as well. So that should be, well, what is the number of nodes? Well, it should be the length of the mount. So number of nodes, and yeah, and then we might want an adjacent list. So for, again, we want to do that, and then we want to loop through A, B, and edges. Like we guarantee that each element in edges is going to be a length to list, so we can just do that. We can just do adjacent list A append B otherwise, yeah, so after that we can just do so after that we want to do a DFS. So DFS on 0. So we have a node which is an int. We don't have to return anything, I think. Yeah, we just want to get like all his children basically. Maybe we should have prev here as well. I think that's how you do it. Oh wait, I think it's this. Equals empty. So the reason we want this is, well, for 0, it doesn't come from any node, right? So yeah, we can just do so the parent of the current node is going to be the previous, and now for child in adjacent list of node, we just want to do, well, we want to DFS into each child, and then the parent should be the current node. But we also have to check one thing. So if parent of child is not empty, well, if it is not empty, that means it is that means like it has been seen before, and therefore well, because each node can only have one parent, and like the parent is not empty right now, so that means like the current node is definitely not the parent of like the current child node. So that means like it has to be its parent. So we want to skip that. Otherwise, like we will do a DFS that should set the parent node, like the parent array here. So yeah, I think we should have a checkup first. So return, just do -1 for now. Let's just check like whether our DFS algo works. So we have 10113. So I don't know why this is set as, I know why. Wait. We should do if child is not equal to prev, right? That should be more correct. Or is it node? It should be node. It should be node. It should be node. But it should be equal now. So like the node is the parent of the child, right? Wait. Oops, I think I messed that up. Let me think about it. So right. Maybe we can just do it like this way for now. Well, the only issue is like we have set the parent of the root to empty, but well, like let's think about it, right? So when we have 0 here, the parent node, well, it will be set to empty, but then like when we get to 1 here, it's going to look at 0. Yeah, well, let's just do it this way for now. It's not as clean, but so parent of 0, just set it back to empty here. Well, yeah, the only issue is like maybe we can do like no child. Maybe that's a bit better. So no child. Yeah, I'm pretty sure that would be a bit better. Yeah, that should be -1 now. Huh. Right, so we have node 0 here. Node 0 previous is going to be, well, -2. So 0 is set to be -2 here. And then loop through all the child. So if child is non-empty, but should be the parent of child. Yeah, okay, we have what we want now. And then the other thing is we want to find where Bob starts. Well, but actually it doesn't really matter, because like the only thing we want is we want to know the depth of, well, Bob's node. So maybe you can do it in the DFS as well. So we have depth, which is an int. We set it to be 0. Depth +1. So if we do that now, we should be able to find the depth. So let's have, I don't know, Bob depth. So when we recurse into Bob's node, so if node is equal to, just say Bob, right? Yeah, it's equal to Bob's starting node. Well, we can set the Bob depth to be depth. I think we need non-local here, because we're updating something outside. Yeah, okay. So we have the depth here. Yeah, and then we basically just want to like keep recursing like up. So while we also should have cur node. So this is the Bob's path update. So cur node should be just Bob's node, and then while parent of cur node is not equal to no child, we want to update the amount array here. So we should just do, maybe we'll have current depth as well. So that will be Bob depth, and then yeah, so we want to update the current node first. So amount current node. Well, how do we want to update it? So so if Bob's depth divided by 2, yeah, so Bob depth is going to be, like, let's say Bob depth is 2. Well, we want yeah, we have to do it for like both like the even and odd case. I think odd would be a bit easier to deal with, maybe. Actually, let me think about it. So yeah, maybe we need like 2 different cases. So we have if Bob depth modulo 2, so that will be if it is odd. So if it is odd, let's say it is like 5, so 5 4 3 2 1 0. So I think if we do Actually, what do we want to do? We want to find the midpoint, right? I think like beforehand we want to find the midpoint. Right. Well, actually, if this is odd, if we just divide it by 2 and then round it down, we will get the like the largest element that we should not update. So Bob depth we want the cutoff depth that should be Bob depth divided by 2, and then here well, let's think about the even case as well, maybe. So if it is even, something like this, when we do a clean divide, it should get like the exact midpoint. Right, so we can do something like while I have an idea on how to do this cleanly. So we can just do while current depth is greater than cutoff depth. If that's true, we can just set the value to be 0. So cur node equals 0, and then want cur node to be the parent of cur node afterwards. And then here we'll just do if Bob depth. So if Bob depth is even, we will have reached the cutoff depth. So we want the amount on current node to be equal, well, to not Bob depth. The amount of current node should be a halved. So actually, let's print out the amount as well. Let's check if we have got that right. Oh, where did I? Oh no. Oh, I forgot to do this here. I think that's why. Wait, do we have to correct stuff now? So that should still be 2. Yeah, that's correct. Yeah, that should be set as 2. And then 2 0. Yeah, that got set to 0. So yeah, I think that's correct. So after the update, we want to run one final like recursion or whatever you want to call it. So we have, so let's do like traverse, and then if we just return traverse at the root, we should get the answer. So that's how we should set up traverse. So it should return maximum path from current node to any of its leaf nodes. Yeah, so we have the current node, of course, and then we want to return the maximum here. So what we can do is we can just do for so we have a running maximum. So let's set it as like best or something. We really shouldn't set best to be, well, like 0 or something, because like maybe all of his children has like negative cost like this case here. So we should set it as minus infinity. And then we want to like look at all of its children. So for child in adjacent list node, again, it could be its parent. So if child is equal to the parent of its own node, we just want to continue. Otherwise, we want best. Well, we want to get the maximum of we want to get the maximum like of either the current running best or traverse. We want to traverse on the child. So yeah, so we have that, but we also have to check one thing. So if adjacent list node, if it is empty, oh wait, actually it will never be empty. If it doesn't have any child, it is still connected to the parent. Oh, I know what we can do. We can just do a count here. So that would be the number of children seen. So if count is 0, it doesn't have any child, so we can just return the amount of the current node. Otherwise, we want to return the best, the best we can find. Like we're forced to like keep traversing, right? Like if they're all negative, we still have to go to like one of them. But then we want to add the amount for node. So that should give us like the best path for each of these. Yeah, I think unless I run into edge cases or like the setup is wrong. Yeah, okay, well it is correct. So yeah, this problem is definitely like a harder medium because like, well, it's not hard to find out the solution, but it could be a bit hard to like code out all the stuff because like you have the initial DFS that you have to do, and then like you have to find where Bob's node is, and then like you have to like know that you have to update the amount, and you have to see that like because Bob is moving to root, he only really has one path, and then at the end like you want this like, I guess you can call this like a 3DP like at the end to solve this. So yeah, I would say this is like a hard medium. Yeah, and I think the acceptance rate is not high as well, right? Okay, it's like 50%. It's not too bad, but yeah, this one is definitely like one of the harder mediums. And yeah, so thanks for watching. I'll see you guys tomorrow. Bye.